All right. What's the probability of getting a head?
1/2.
1/2. And what's the probability of getting a 6?
1/6.
1/6. So what's the probability of getting a heads and then a 6?
1/12.
We could put that into our calculator if we want to, although I'm pretty darn sure that that is reduced. 0.083, I guess. 8.3% chance of getting a heads and then getting a 6. Is this making sense to you guys so far? Okay. Last page. All right, this is some true information for you. Has anybody known somebody who's had their ACL repaired? Pretty common basketball injury. A lot of twisting in basketball. All right, the probability that the surgery is successful is 0.95. 95% chance, that's pretty good, right? All right, let's find the probability that 3 ACL surgeries are successful in a row. So it's this surgery is successful and this surgery is successful and this surgery is successful. So what's the probability that the first surgery is successful? Jessica, what do you think? What's the probability that the first surgery is successful? 95. And what's the probability that the second surgery is successful?
Is it 95?
It's still 95, yeah. Although there is something that I'm not considering in this, that each surgery has a 95% chance of being successful, there is one thing that actually could make it dependent. Can anybody think of what would make the chance of a surgery being successful dependent?
Different doctors.
Yeah. Like you might have one surgeon that is absolutely fantastic and they have like a 99 success rate. You might have a doctor that does great and maybe has a 70% success rate. But in general, 95% chance. Okay? So what are the chances that all 3 are successful in a row? 0.95 times 0.9 times 0.95, which is 0.95 to the 3rd power. 0.857. Okay, let's talk about this really briefly just to make sure that you guys are okay with this. Why isn't it that it's a 95% chance that all 3 are successful in a row? Why wouldn't that make sense to you? Because if you've got a 95% chance for every surgery, then why isn't it 95% chance when we have 3 of them in a row?
Could not be the same type of injury.
Could be. It also could, I mean, it's like if I said, okay, roll me a 6 on a dice, you'd have a 1 out of 6 chances, right? Okay, would you be willing, like if I said, here's, I'll give you $10,000 if you can possibly get a 6 on a die. You'd go for it, right? Possibly getting $10,000, especially if I said, it charges you $5 to get it. But if I said, okay, now you have to get a 6 on a die, I'll give you $10,000 if you get a 6 on a die, but you have to get it 10 times in a row. Easier or harder to do? Or the same? To get a 6 10 times in a row. Hard, right? Because it's each time it's 1/6, and the chance that you would get that 1/6 right 10 times in a row, that's hard. So 3 successful surgeries in a row have less possibilities. Find the probability that none of them are successful. All right, what's the probability that it's not successful? If the probability that it is successful is 95%, what's the complement of that?
0.05.
Right, 5% of surgeries are not successful. So if none of them are successful 3 times in a row, that's 0.05 times itself 3 times. Now, when I did that, I got this on my calculator, 1.25 e to the negative 4. Did you guys get the same thing? What does that mean?
1.25 times 10 to the negative 4.
Right, which means we're gonna move that decimal place 4 times to the left. So the answer is 0.000125. If it was e to the positive 4, then we'd move the decimal place 4 places to the right. So this is very, very small. Okay. The last thing says, find the probability that at least one of the 3 surgeries is successful. Now, we could do this in a very complicated way. We could say that, all right, so if at least one of them is successful, it could be that all 3 was successful, because that means that at least one was successful, right? Or I could say the first 2 are successful and the last one was a failure. Do you guys agree? That's at least one success. Or I could say the first one was successful, the second one failed, the third one was successful. Okay, that's another possibility. Or if I could say fail, success, success, that's at least one. Or success, fail, fail. Or fail, success, fail. Or success, fail, fail. Nope. Already did that one. Fail, fail, success. These are all the options where at least one of them succeeds. Do you guys agree? But instead, I'm a mathematician, so I'm going to be lazy, and I'm going to take the complement. Because if at least one of them is successful, what's the opposite of that? At least one is successful.
At least one is unsuccessful.
Well, not really, because if at least one is successful, the only opposite of that is that they all fail. Because if one is a failure, still 2 are successful, and that's still a good thing, right? So the only thing that really is not on the list is fail, fail, fail. So what I'm going to do is I'm going to figure out the probability that they all fail and subtract that from 100% instead of figuring out all 7 of these and adding them up. Which I could do. I could figure out the probability of all 7 of these, add them up, and that would be the same answer. But we've already figured out the probability that all 3 of them fail. Well, that was 0.000125, right? Right here. So if we just take 1 minus 0.000125, we'll get our answer. It's called the complement. 0.999875. So that's the probability that at least one of them succeeds. It would be extremely rare for all 3 of them to fail. Okay, so your homework, and this is due, let's see, I think tomorrow I'm going to make a work day on this assignment.